All right, I am now back with problem number 7, the ladder problem. We are told that the ladder is slipping down the wall, and let me get my pen going. Come on, little pen. Okay. So there is some rate at which the ladder is slipping down the wall. And over here, this says that the rate of change of the distance RQ is increasing, but it's increasing at a rate 3/4 that at which this vertical distance is decreasing. So what I'm going to do is I'm going to say R is a positive number. And I'm going to call, that's going to be my rate between the two of them, or a particular rate of change. So I've got my horizontal distance x, I've got my vertical distance y. And y is changing at a rate -r. X is changing at a rate that is 3/4 r. Now we are supposed to figure out what the distance RQ is, so we are trying to solve for x. Now, to get this party started, we need Pythagorean theorem to just begin a relationship of x and y. Whoopsies. Oh my goodness. Okay. So x squared plus y squared equals 40 squared. I'm taking the derivative with respect to time. So I'm getting 2x times dx dt plus 2y times dy dt is equal to 0. And I am going to divide by 2 and subtract over to the other side so that I have x times dx dt is equal to -y times dy dt. Now, dy dt is going to be replaced with -r, and dx dt is going to be replaced with 3/4 r. That gives me at this point 3/4 times r times x is equal to, I'm going to have these two negatives kill each other, and then we have r times y times dy dt. Oh, wait, dy dt was replaced. I can do this. So I have those two negatives cancel each other, and it's r times y. Now, both sides can be divided by r. So at this point now I have 3/4 times x is equal to y. Still don't have the answer. So what is the relationship between x and y? Good old Pythagorean theorem, but now I have the joy of finding an equation for y with respect to x, which means I have to deal with a square root. And I have the hypotenuse squared minus the leg squared is what y is equal to. Now I'm going to bring that over to the relationship I have. 3/4 x is now equal to the square root of 40 squared minus x squared. And in order to solve this equation, I need to square both sides. That's going to give me 9/16 x squared being equal to 40 squared minus x squared. And now I can add an x squared to both sides. And so I'm adding 16 plus 9 to give me 25. So I've got 25/16 times x squared is equal to 40 squared. And now I'm going to multiply by the reciprocal. So I'm just leaving that as 40 squared. multiplied by 16 over 25. And now that I take the square root, I'm very glad I left that as 40 squared. So square root, and I'm getting x equals, and that will end up being 40 times 4/5, which is then 8. 8 times 4 is 32. Oh my goodness, I think we've got an answer, 32. Wabam. And question 8. Here we go. Radius of a circle is decreasing at a constant rate. So I'm going to put down dRdt is negative because decreasing 0.1 centimeters per second. Now, in terms of the circumference, what is the rate of change of the area of the circle? So, I'm pushing buttons. Okay, here we go. I'm trying to find dAdt, but in terms of the circumference. So to start things off, I want to realize that I need a relationship between A and R when this is a circle. So area is pi r squared. I need to take the derivative with respect to time. That gives me dAdt is equal to constant multiple pi times, and then blah squared derivative is 2 times blah times the derivative of that baby with respect to time. Now, we are told that dRdt right here is negative 0.1. Nah. In terms of the circumference, that is the formula for circumference. No, I don't want to insert a menu, so stop asking me, but I guess I'm just stuck with it for now. Okay, anyway, so the rate of change of area with respect to time is negative 0.1 times the circumference. Woohoo! Moving on to question 8. And I really want to get rid of insert menu. It's bugging me. How do I tell you to stop? I don't need it. No, go away. Okay, looks like I'm stuck with it. All right. We've got a base of a triangle is increasing, so dB dt is positive 3 inches per minute. The height is decreasing at 3 inches per minute. dH dt is negative 3. Which of the following is true about area? And looks like we're being asked about area increasing or decreasing. So we've got a triangle. Area is 1/2 base times height. To get out of fraction land, I'm going to multiply the 2 over to the area. And now let's take the derivative with respect to time. So I have 2 times dAdt equals, and now I'm using a product rule, so I have keep the b multiply by dH dt plus keep the h multiply by dB dt, and I can plug in the positive 3 for dB dt and the negative 3 for dH dt. That is going to give me 2 times dAdt is equal to, and I'm going to switch that subtraction around, so 3h minus 3b. I can factor 3 out. Yay. And then the question was asking me about when is area always increasing? Is area always decreasing, or something certainly not remaining constant? So I need to look at who is causing the positive negative. H minus B is going to determine whether dAdt is positive or negative. So H minus B, if I look over here, no. So decreasing. area is decreasing when h minus b is negative. And that means I'm going to have do, which means b greater than h is decreasing only when b is greater than h. There we go. Now on to the lighthouse duo of problems. Oh, no. Just a little bigger. There we go. Okay. So we have some speeds. 15 kilometers per hour is how fast ship A is traveling due west toward Lighthouse Rock. So that means dx dt is negative because x is shrinking, negative 15. Then I have ship B. Ship B has a speed of 10 kilometers per hour and it is traveling north. So that is causing y to increase. That means dy dt is a positive 10 kilometers per hour. And we are being asked to find the rate of change of angle theta when, and there's our when information. So we'll put that in at the very end. All right, now, if I need to deal with theta and both of these sides, then I'm going to use tangent. Anytime you have a right triangle and theta is involved, you need to use sine, cosine, tangent, or one of the other three. So tangent theta is equal to opposite over adjacent. And now I need to take the derivative with respect to time. So tangent, derivative of tangent is secant squared of blah. Give mommy her baby multiplied by derivative of baby with respect to time. Then I've got a quotient rule. So I go low d high minus high d low. Square the bottom and away we go. And now I can put my when information in. The when information is when x is 4 and y is 3. I think I see a 3, 4, 5 Pythagorean triple. Or I can Pythagorean theorem and get the 5 on that hypotenuse. So now filling in the information. I've got secant squared. Secant is cosine's reciprocal, so that means I'm looking at hypotenuse over adjacent. On the other side of the equation, I have x is equal to 4. I'm going to change colors because I feel like it. And dy dt is 10 minus y is 3 at that time. Dx dt is negative 15. And then 4 squared would be 16. And then it's just a matter of cleaning up this lovely thing. So d theta dt is equal to, I've got 40 plus 45 over 16, and then I'll be multiplying that by 16 over 25. Oh, yes. No 16. So now it is 85 over 25, which is some number. That's not very helpful. Okay, if I divide by 5, 85 divided by 5 will give me 10, and then I've got 35 more. 35 divided by 5 is 7, if I am correct. So 17 over 5 is d theta dt. And, oh, radians per hour. Or is it hours? Yes, radians per hour. Okay, next, same scenario. different thing to find. This time we are finding the rate at which the distance between the two ships is changing. Same scenario. I'm going to call that distance z since I've got an x and a y going. And I need a relationship between x, y, and z. So Pythagorean theorem, it is x squared plus y squared equals z squared. Taking the derivative with respect to time, I'm getting 2x times dx dt plus 2y times dy dt is equal to 2z times dz dt. And those 2's are out of here. And now I need to fill in the when information. I'm finding dz dt. And we already took a look at the when information being that x is 4, y is 3, forcing the hypotenuse to be 5. And plugging that in, I have x is 4, dx dt was negative 15. And before I forget, dy dt was 10. And y at this moment is 3. Z at the moment is 5. And now I have 4 times negative 15 to give me negative 60, plus 3 times 10 is 30. And so I've got negative 30 divided by 5 gives me negative 6 is dz dt. So the rate at which that distance is changing is negative 6 kilometers per hour. Yay, I'm done. I'm going to have dinner.